Thank you very much, Dan. Take it away. Thanks. So, before we talk about the pipeline operator, let's talk about method chaining. It's pretty awesome, right? So, say we have an array of objects. These represent cities. They have a name and a population. And what we want to find out is what is the list of city names for cities with more than 1 million people in them, sorted in the order of increasing population. As a first step, we filter out the cities that have less than 1 million people in them using the filter method. Then we sort them by population. This is all using standard methods on array prototype. And then map by city name. So at each step, we're passing in a function, and this gives another array as output, and then we call another method on the output. So this works pretty great. What if you want to do this with your own thing? So say this sort thing, calling .sort with this sort of function, is really common. It comes up all over the code base. So you want to factor it out into a separate function. Or another case could be maybe it just gets really complicated. And so you want to put it in a separate place and not have everything be inline. So great. Let's make our own thing to go in the pipeline. So we have this sort by population function, which takes an array as an argument. It sorts the array by that, and then it returns the results. And then when we use it, well, we do cities.filter the same way, and then we call this sort by population function around that, and then you chain map off to the end. Oh, that's not so nice. Previously, everything was really simple left to right, and now just because we have a function call, we have to go and interrupt the whole flow. Well, okay, so to fix this, let's instead make it a method. We put array.prototype.sortByPop, a function on array prototype. So we're going and modifying the existing prototype in order to do this sort. And instead of taking in the array as an argument, it takes it as this. So given this array of cities, when we call filter and then sort by pop as a method on the object, and then map, then we get out the same output that we were expecting. This is a little bit problematic, though. Say we have 2 modules that do this. So we have this one module that's sorting cities that has this array prototype sort by pop method. And we're also doing some music processing. So we have some musicians with popularity. OK, they both add this method sort by pop to the prototype. But one of them is sorting by popularity, and the other one is sorting by population. Sorry, not sorting, but filtering. Then when we have a combined module that deals with musicians as well as cities and needs to filter their pop, it's going to be problematic because big cities here on the left is trying to call this sort by pop function, whereas many fans is trying to call this pop method. But whichever one gets loaded first is going to be messed up because they're both clobbering the same thing. They're both reading off of array.prototype. So there's a clash. So going back to this example, I think we need to step back a step because going and modifying array.prototype is just not a workable strategy. Because not only is there the issue of what if you have 2 modules clashing with each other, there's also when new versions of JavaScript come out that modify array prototype, you may have something that's completely unsuitable and shadows this new functionality. So going back to the original version, which was kind of out of order, but at least it worked. At least you can have sort by pop in 2 different modules, and because of lexical scoping, you could define the same named function in different modules, and they don't clash. It's just the code that's next to it, based on the principles of JavaScript, will access the right one. So this is really what we want as the base. What if you could do something like this? The double colon here. So inside of the chain, We call this .filter method, and then we want to call out to sort by pop, even though it's not a method. We use this double colon operator called the bind operator to look up this thing, not from array.prototype, but instead from the local lexical scope to do the operation and then continue on to the map. So what this does is it's basically like call. So JavaScript has this thing, function prototype call, where given a function, it calls that function with a given thing being what's called the receiver, or the this value. So here, when we do f.call object x, then in the body of the function f, this will be assigned to object, and then x will be passed as an argument. So in this language proposal, the bind operator proposal, object : f of x desugars, or it sort of translates into f.call of object x. But what is this JavaScript? I never heard of that. Maybe we're looking into it. So TC39 is considering the pipeline or bind operator as a potential future extension of the programming language. But who is this TC39 thing? Well, remember ES6? Maybe you've heard of it. JavaScript now has a bunch of new language features. For example, destructuring lets you do, in this case, swap two variables in a really intuitive way. If you have x is 1 and y is 2, and you do yx equals xy, then it swaps them because it creates an array and then it assigns to an array that's on the left-hand side that says what you're writing into. So who is this TC39 group that keeps messing around with my programming language? Well, we're a committee of ECMA International, a Geneva-based standards organization. I just came from Geneva yesterday, actually, with JavaScript developers, implementers, so people who are making JavaScript work inside of web browsers and Node.js and other systems, as well as web frameworks and libraries, and programming language academics, and many more people. And we all get together to work on this. This is the JavaScript specification. It's a big HTML document. Please don't print it out. It would be 1,200 pages or so if you were to actually print it. But it's really nice to navigate online. There's all these sort of linking features. But this describes in sort of mind-numbing detail exactly how every single little aspect of the JavaScript programming language itself works. And we develop it here on GitHub. We have a GitHub repository that has the source for this HTML file, and it's generated with language that sort of an HTML superset with Markdown. And in addition to developing on a GitHub, we also have meetings. Every 2 months, we meet for 3 days, and we review things that have gone on in GitHub, as well as move proposals through a stage process. So TC39 stages, you might have heard of these, but just a sort of quick recap, we have stage 1, you have something, just an idea that we're talking about. At stage 2, the committee agrees, yeah, we want to do this idea. We have a general idea of what that is, and we want to do something. At stage 3, the details are really subtly worked out, and it's ready to, from a design perspective, it's almost finished, but we need more feedback from draft implementations and maybe some usage. And then at stage 4, we have a full standard that's fully in the language, and at this point you say, this is JavaScript, or at least it's part of the current draft standard that will then be ratified within the next year. So here's a quick history of the bind operator. TC39 has been discussing making a change like this since 2012. It was developed by committee members like Dave Herman and Kevin Smith, and in Babel in 2015 it became implemented in Babel, where popularity sort of started to increase from there. This is at least in discussing with developers, this is for some people the reason they say, yeah, I still use Babel, and even with Node having new JavaScript features because the bind operator is so useful. But even though it got some positive feedback, it was deferred and not put in ES6 because we wanted some more time to really think it over. So here, TC39 used to use a wiki for development before transitioning to GitHub, and here's a screenshot of the old wiki page that talks about the bind operator. But there's something funny about it. The way that this works. So in the bind operator, you're always taking the thing that you're chaining as the thing that goes in this. But a lot of JavaScript developers find this to be somewhat confusing. There are a few different rules that you have to remember. And especially when people talk about functional programming, one of the cited advantages to functional programming is you don't have to think about this as much. And in this case, we're not even talking about methods. We're talking about extra functions. So it's especially weird to use this when it's not a method. Anyway, there are several kind of intuitive reasons why the bind operator passing the argument in this seems a little bit odd. Maybe it's not fatal, but let's consider some alternatives. And the alternative I want to talk about is the pipeline operator. So here's another example. So say we have a bunch of functions that take an argument and return something. So here, these are kind of silly. Double say will concatenate a string with itself, putting a comment in the middle, and things like that. We could chain them together by having this nested set of function calls, which works. And then the pipeline operator offers this convenient syntax for that, which is equivalent, where you do hello, you pipe to double say, you pipe to capitalize, and to exclaim, which is equivalent to just doing this function call. So instead of being equivalent to a use of .call, it's just equivalent to a bunch of function calls that are nested. History of this proposal came a little bit later. It was specifically proposed as sort of an alternative to bind. They could coexist, but they're really solving a lot of similar problems. So an online contributor, Gilbert, created a repository proposing this in 2015. And in November 2017, it was proposed to TC39. And it's currently at stage 1. Now it's implemented in Babel. And the current idea is to pursue multiple implementations of different variants to help make some design decisions. I wanted to go into a little more detail on some of these design decisions. And first, this is async await. So what I'll show you now is sort of a peek at what TC39 does. We get together and each person makes a bunch of slides like this, and we go through and we explain, okay, here's how this edge case would work, or here's how this would interact with that, and gets into some very minute details. So for async await, going back to that example that we had before, here everything looks great. It's kind of messy to have things all nested, and now things are not as nested with pipeline. Instead of trying to read the logic flow right to left, you read it left to right. So what if when we're refactoring the code, it turns out you're using some other locale, and the browsers don't have proper locale support for the case conversion for capitalize. You're not going to always pass in hello here, but you may pass in something in some other language, and we just don't have support on the client. So we send it to the server for proper locale-dependent capitalization. And so we want to await capitalize on the server. Now it's an async function. So with nested function calls, this is handled straightforwardly. So here, if you try to call this normally and you don't put in await, JavaScript's going to say, oh, that's great. Sounds like by appending an exclamation mark to the promise, you obviously meant that you wanted to convert the promise to a string. And JavaScript happily gives you back object promise with an exclamation mark. And in fact, pipeline lets you do that as well and get back your object exclamation mark. But probably you didn't mean to do that. Probably you meant to await the argument. So with nested function calls, what you can do is just put an await there. Await takes the promise and gives you the value after yielding to the event loop and waiting for it to happen. And then we get out the result. Of course, you can only do this within an async function. And the problem is with pipeline, with the simple version of pipeline, you don't have the ability to do that. You would have to break out of the pipeline and do then, because await isn't a function. You can't just use it wherever you can use functions. You notice that here we don't even have parentheses around the argument. It's a special keyword. But oh, this is a typo. But so you could also phrase it like this. You could also put an await around this sub-expression and pipeline to explain. But anyway, this still looks wrong, because you really want to have the await be after the capitalize and before the exclaim. You want to keep using the left to right ordering. So there are a few different proposals that we're considering for how to solve this. One is that you would put the await here. We would have await capitalize be something that you could put in the pipeline, and that would make it so that if you have await capitalized just like this, then then that means that you want to await the results of capitalize. The thing is, though, it's funny, but await of any expression already has semantics. It already has an interpretation in JavaScript. If you await any expression that's not a promise, it will happily, go back to the microtask queue. It will do a little pause, and then it'll say, oh, here's your value back again. JavaScript is happy to wait for anything. So if you put parentheses here, then JavaScript would bring us back to our old friend object promise with an exclamation mark. That's sort of something we would have to live with if we went for this alternative. Another idea that we were considering is we could put a pipeline and then await just by itself in another pipeline. And you can just treat it as if it's a function, but it's treated specially here. So, different options. Another issue, which is a little bit more subtle, is how to handle additional parameters for functions. If you want to, in your pipeline, pass more than just the thing on the left, but pass more arguments, how exactly we should handle that. So the plan from here is to pursue two different proposals, which are nicknamed internally the F# pipeline and the smart pipeline proposals. Write specifications and documentation for each. So this is all available on GitHub right now. There are two community members who are not even TC39 members, but people from the open source world who are just really interested in this and jumped on the opportunity to think through all the issues and write up detailed proposals for this. This is James DeJoya and Joshua Choi. Implementations are in progress in Babel for these two options. And so the idea is that we'll develop, once these are all developed and people can try them out, we'll try to come to a community-based decision about which of these sort of three options we pursue, whether it's the F# pipeline, the smart pipeline, something that's more like that original option, the bind operator that I mentioned, or maybe we'll come up with something in the middle or some combination. Or maybe it'll turn out there's no good solution to all the problems. But the idea is to stay at stage one and continue investigating this. And yeah, and then propose to TC39 whatever we decide. So in the stage process, to get to stage two, well, sorry, I'll skip these slides and just jump to getting involved. So I think we could definitely use your help in TC39 in advancing the pipeline operator. For example, on GitHub, we've been having a lot of discussion about the pipeline operator. You know, we'd like to hear about whether a proposal would work for you, if there's any missing pieces, if it seems weird how it works in a particular way. And in the case of the pipeline operator, basically all the work has been happening on GitHub so far. We've had some committee discussion, but the majority of the discussion has been here. And we've sort of talked about every aspect of the proposal. For a proposal to go through the process, to get to stage 4, conformance tests are used. So there's a conformance test suite called TC39. This is used to make sure that all JavaScript engines, so web browsers and Node and everything else, agree on what the proposal is and what the language feature is and how it works. It's important because when we don't have these tests, then it turns out in practice different implementations differ in their semantics. So maybe in one browser your code works, and in another browser it doesn't work. Or maybe it works in both but works differently. So TC39 is another open source project that you can join. You can just go on the repository and find bugs and fix them. Here's a pull request for big-int tests. When it comes to pipeline, it might be a little bit early for tests because we haven't chosen the variant, but at the same time, maybe it's not, because these tests will be useful for developing the implementations in transpilers, in Babel and in other cases, and then it'll just be, you know, once we select it, it'll be ready. Documentation materials. So this is one of the trickiest areas. When working with documentation and education, we really want to understand the different possible mental models that people will approach things with. You know, not everybody's going to have the whole specification in their head when programming in JavaScript. You're going to have some fraction of it. For example, like this issue, there are a bunch of different rules, and you can get a lot done without thinking in every single piece of code that you write exactly how everything works. So when we're trying to analyze proposals, we analyze them according to different ways that people might think about them. And we also want to have educational materials that are accessible to these different perspectives. So for the pipeline proposal and the bind proposal, we have these initial explainer documents, but what we don't have yet is a lot of help from educators in interpreting the different intuitions, as well as figuring out what sort of introductory materials we would have for them. And of course, implementations. So these days, all the major JavaScript engines are open source, and there are also many different tools projects that are open source, and you can just jump in and contribute. Most JavaScript engines have a policy of only accepting features once they're at stage 3, once they're somewhat final. But it can still be interesting to prototype. The exception is that Babel encourages earlier stage proposals, as well as many parsers or syntax highlighters especially syntax highlighters, allow earlier proposals. But you know, external plugins or features developed behind flags can be really useful in investigations. So, interested in writing a pipeline implementation? It could help us answer some interesting questions, like about whether pipelines can be optimized away in certain cases. Of course, it's also possible to attend TC39 as a delegate. This involves joining ECMA. Please let me know if you're interested, and I'll connect you with the right people. So, I encourage you all to get involved in TC39 work, and you can go to our website to get started on GitHub. Pipeline is at stage 1, and it provides more composable chaining operations so that you don't, just to put things left to right, you don't have to clobber prototypes. You can just import functions and chain them. And I'm Daniel Ehrenberg, or Little Dan, and thanks for listening.